Hello and welcome back. Let's talk a little bit more about separable differential equations and initial conditions. So I suppose I should talk about some different notations. So in the past video we used dy over dx, but we should also note that this is equal to y prime or y prime of x. But we also have other notations such as d squared y over dx squared, which is the second derivative. Now we would call this y prime prime or y prime prime of x, but when we get into multiple derivatives, we have one more notation we can use, and that is y, and in brackets we put our order of derivative that we use, and we could of course put an x here if we wanted to. Now my marker's running out a bit. Hopefully this one's good. But yeah, that makes it pretty easy for marking things down, because say we had the fifth derivative, it would be a lot easier to write y and then in brackets 5 instead of y prime 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 prime. It's hard to see what's going on there, right? So anyways, let's look at one more example of separable differential equations. This should be a pretty quick video, but our example is, and we're going to use this new notation we just learned. That. And so we could go ahead and separate this, or we could just use general knowledge to solve. But first, I'd like to introduce initial conditions. So for this one, we are given that y prime of 0 equals 0, and also y of 0 equals 0. So that just means when a value of x equals 0 is plugged into our y equation, it's going to equal 0, and same with y prime. So we can get that our regular y prime is just going to be the integral of this, which is 1 over 5 x to the 5 plus 1 over 2 x squared plus c. And now let's use our initial condition. We have 0 equals 1 over 5, 0 to the 5, 1 over 2, 0 to the 2 plus c, and so we can see from here that, and we're going to call this c1, sorry, c1 equals 0. Okay. And then we can also find our y by integrating both sides of this with respect to x. We're going to get 1 over 30 x to the 6 plus 1 over 6 x to the 3 plus c2. Of course, our c1 can be omitted because it equals 0. And our y of 0 is 0, so we plug this in. What we're going to get is that c2 equals 0, because this is 0, this is 0, this is 0, so c2 can only equal 0. So our final solution is just that. Now this wouldn't be the general solution to this differential equation since there's initial conditions. The general solution to this, ignoring the initial conditions, we would actually get y equals 1 over 30 x to the 6 plus 1 over 6 x to the 3 plus cx plus c, and we will label these c1 and c2. So you can go and figure that out yourself, but really I don't think it's that complicated. The only complicated part would be this, and that's because we're integrating a c, which is going to give us cx. So thanks for watching this video. In next video, I'll have to decide what we talk about. There's an easier topic, but there's a topic that kind of eases into that, but you don't really need to know it yet. I hope to see you in the next one. Thanks for watching this one.